Hello everyone, welcome you all to the 21st session of Pandas DataFrame. I am going to continue writing on the same IPYNV file in which I have conducted the last session, that is the 28th session. Before moving ahead with our discussion, let's write nutrition.shape and access the shape. The nutrition dataset is having 8,789 rows and 75 columns. Let's also access the first 5 rows here. So nutrition.head, this will give me the first 5 rows here. Fine. When working with large datasets like this, which has more than 8,000 rows and 75 columns, it would be really nice if we were able to quickly filter the labels we were interested in. And the good news is that to achieve that conveniently, we could use filter method. It's the same filter that we saw in the series section. But it's now got superpowers because it allows us to filter the index as well as the column and even both if we want. So let's take a quick look at some concrete example here. I remember my friend Angela telling me that the octopus has a lot of cholesterol and that the doctor asked her dad not to eat any octopus. So let's say I want to look for octopus entries as a first step to independently verifying this claim. So I can write here nutrition.filter. Fine. So I'm filtering this and I will set the access to 0 because I'm filtering in the index dimension of the nutrition data frame. That's where we have our food items, the names of food items. So I want to filter in this dimension. And then I will use the like parameter. So I will say, I will write here like is equal to octopus. Here I am putting O in uppercase. Fine. Now, if I run this code, let's see what I'm getting. And there I have it. It looks like octopus has 41 milligram of cholesterol, which honestly does not sound that bad. But remember, using this like parameter here is similar to using a literal case-sensitive condition. Let me make it more clear to you. So let's say, first let me copy this code and let's paste it here. And so if I drop this uppercase O from here in octopus and I put small case O or lowercase o, and then I will run it. Can you see? I get back to other matches, to other food items that belongs to the same family of foods, but were not initially selected because they were not capitalized. The good news is that this method also supports regular expression, and this is pretty good opportunity for us to use them. So let's filter this with regex. So for filtering it with regex, let me just copy this piece of code from here, paste it here, and simply, instead of this like parameter, everything will remain same. This access will also will remain same. I'm going to change this like parameter to regex, R-E-G-E-X. That's all. If I run this piece of code, what I'm getting? It looks like I only got the lowercase octopus again, which I was getting here. Same thing I'm getting here. So what do we do here? So we have two options. First, we could include the character class for the O's here. The way we do character classes is within square brackets. So let's copy this from here, paste it here, and instead of this here, put square bracket first. Put square bracket here. Fine. Thereafter, one is this small lowercase o, and second thing that I need to put here is the uppercase o. So we specify a range or a sequence of characters that we want to match, and the order doesn't matter here. So, but I will say here uppercase or lowercase o followed by access is equal to 0 again. So let's give it a try. Let's run this code and see what I'm getting. Very nice. So we are now matching all the three. This is my uppercase O and these two are my lowercase o. So why did this work? It's because we said using regex match all sequences of texts that begin with uppercase or lowercase and are followed by lowercase ctopus, and therefore we got all the three matches. So there is a nice regular expression trick here, which we will explore when we talk about working with text. But let me show it quickly. Instead of using the character class to indicate that we want both uppercase and lowercase o, we could ask regex to completely ignore case for this pattern. In other words, we can say match this pattern in a case insensitive way. And the way we specify that is by adding at the beginning of our pattern a question mark and I within parentheses. So let's do it. Let's copy this from here, paste it here, and simply what I need to do, I have to first remove this square bracket. Thereafter, I have to put this parenthesis, and inside that I have to put this question mark and this small I. Fine. A question mark, small I within parenthesis, and let's give it a try first. So let's run it. As you see, the output here is the same what I was getting here when I was mentioning this lowercase o and uppercase o inside the square bracket. Fine. We get all three octopus matches in our dataset just like we did above. Now, don't worry if this looks a bit weird right now by using this question mark, small I flag here. We are simply saying that we want the pattern to match without case being considered. In regular expression, this is known as modifier, and in this particular case, the I is short for insensitive of case. So far, we have filtered the data frame along the index axis. Remember, we keep specifying axis is equal to 0 everywhere. Here also you can see. Here also. Fine. But as you could probably imagine, by simply changing the axis argument here, we could filter along the column dimension as well. In fact, let's go ahead and do both at once. So let me write it here. We are going to do filter along both dimensions. Technically, I'm only interested in knowing how much cholesterol Octopus has. So I will go ahead and filter our column axis for cholesterol. So let me copy this from here and paste it here. I will filter our column axis for cholesterol by chaining on a second filter method here, specifying axis is equal to 1 for columns. And maybe to make this more readable, I will use a backward slash. Fine. So now in addition to the like and regex parameters, the filter method also supports another parameter called items. So let me add items here. Items is equal to which allows us to specify an exact sequence of levels that we want to match. So to begin with, I will say, let's say serving underscore size underscore G. I want to match this. So let's copy this from here and in the items, put the square bracket and thereafter put inside this thing because I want to match this, comma. Let's say I want to match servings size underscore this thing, fine. Thereafter, I want to match, let's say, cholesterol mg. So let's put cholesterol underscore mg here. So let's write here cholesterol for mg, fine. Thereafter, at the end, let's add one more thing here, add calories here. So let me copy calories from here. Okay, fine. And let's paste it here. Fine. Now, at the end, what I have to do, I have to specify axis is equal to 1 here. Axis is equal to 1. Now let's give it a try. And so now we get a 3 by 3 data frame as we specified using filter along the index dimension and then the column dimension both at once. Can you see? I'm here axis is equal to 0 and I'm chaining this here axis is equal to. So here I'm applying filter in both the dimensions. To be honest, I did it this way to demonstrate that the filter method can be used to filter along both the index and the column axis. But for a use case like this, if we are targeting this data frame as an end result, I would actually combine the filter method with the lock indexer instead of the second filter method. I will just say here lock and then I will say select all the rows returned from the first data frame. In other words, only those that match this regex and on the column dimension give me this specific column items. Fine. So let's copy this thing and paste it here and let's change it. So I will delete this filter from here. Instead of this, I will write log. Thereafter, I will also delete this item from here and I will put square bracket here. So this is a second square bracket and then I will add all the rows. This I'm asking all the rows and here This thing I will delete and add one more square bracket. And here we go. So let's run it. As you see, the resulting data frames are exactly equivalent. See? So today we have learned filter method with data frames. We used it with the like parameter at the very beginning, the regex multiple times, and then in the end with the items parameter in both the 0 and the first axis. So both the index and the column labels. Thank you for joining me on this exploration of data manipulation with pandas. To unlock a deeper understanding in this field and stay ahead of the curve, consider subscribing to the channel for more in-depth content on AI Ki Pathsala. And if you found today's exploration valuable, a thumbs up would be greatly appreciated. I encourage you to share your thoughts and insights in the comments below. Your contribution fuels the discussion and enriches the learning experience for everyone.